Heyo, welcome to Triangle Sum Theorem Part 2. Yesterday we did an introduction in which we had to find missing angles. We brought up the use of algebra, which will be much more prominent today, in which we will be finding the measure of missing angles. Could be one, two, or all three missing angles, in which we may have to put algebraic expressions and algebraic equations together in order to solve them. The elementary part of this is that all triangles have an interior angle sum of 180 degrees, meaning the inside angles, all three of them, when added together, will always equal 180 degrees. Without this particular law, none of what we're going to do makes any sense whatsoever. So you're always going to say to yourself, is there an amount that I have? And if there is, I can always subtract that from 180 to find the missing amount. Now when we're using algebra, usually it's a better idea to use it as a sum and add those items together as an equation in which everything that can be labeled as an angle is on one side of the equal sign, and on the other side of the equal sign will be 180, because that's always going to be our sum. In our first problem right here, which is slowly making its way into our lives, we're going to start off kind of easy. Here's any normal triangle. As we know, the sum of the interior angles of this triangle must be 180 degrees. So what we're going to do is we're going to set up an equation in which we're going to take the parts of the triangle that we know, including the parts of the triangle that are labeled with unknowns, like the one over here that's labeled with an x, and we're going to add them together and say they equal 180. This equation will allow us to solve for x and find the measure of the angles. 50 plus 80 plus x equals 180. We combine like terms first and we get 130. From there, we're going to eliminate the constant both sides by subtracting 130, and then we get x equals 50. And so that means that our missing angle over here must be 50 degrees. We can check it by seeing if they add up to 180. 50 plus 80 does equal 180. In our second question, we have any ordinary triangle again. In this case, we're already starting with an unknown. Remember, we're going to take all of these parts and we're going to put them in an equation that equals 180. 180 is the only number we're going to need because every triangle has a sum of interior angles of 180. Now in this case, it seems that we have x and x. The only thing we know about the x's is that they must be exactly the same, no matter what they are. So because of this, we can combine them together. X plus x equals 2x. From there, we're going to eliminate the constant from both sides, wind up with 2x equals 140. The last step would be Donald's favorite step, which would be to divide by the coefficient, and 140 divided by 2 gets us 70. Now, if x equals 70, that means that both of these angles, not only one, equals 70 degrees, because the one thing we do know about x is that it's the same as x. Slowly making its way into our picture here is our third problem. It's going to get progressively more difficult, but the same basic procedure is going to be used. We're always going to think about it as being a total of 180 degrees. So while you see these representations coming into the picture right now, you're thinking to yourself, I'm going to add them together to get 180, no matter what they say. I don't care if they say smiley face and hairbrush. Together, they're going to equal 180. So here we have these three parts. I put them into an equation that says x plus 10 plus 3x plus 30 equals 180. I've color-coded the like terms. So we add the x and the 3x and we get 4x. We add the 10 and the 30 and we get 40. From there, we're going to balance the equation by eliminating the variable both sides. 4x equals 140. Divide both sides by the coefficient, which is the number next to the letter, and that's 4. And then 140 divided by 4 will get us 35. Now this isn't really an answer except to what x is. So now we're going to sub it back in. If 3x, where x is 35, is 3 times 35, that's 105. Where x plus 10 is, we're going to substitute in 35 in the place of x, and 35 plus 10 is 45. And all three of those angles must equal 180 degrees together. Slowly, 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 our last example coming into frame here. Pink triangle is going to have three pieces of algebra which together are going to equal 180 degrees. Why 180, you say? I can't believe you're still asking that question. Every triangle has a sum of interior angles that equals 180 degrees. So I'm going to take these three parts and I'm going to add them together and say that they equal 180 degrees. By solving for x, I have my first clue into finding the measure of each of those angles. So I set up the equation, again color-coded with like terms. Green are the variables, yellow are the constants. I add x, 2x, and 5x, that's 8x. I add negative 10 and negative 50, that's negative 60. Now because the constant is a negative, I add 60 to both sides to eliminate it. From there, I'm going to divide by the coefficient, which is 8, and then 240 divided by 8 is 30. Now I know x equals 30, but none of the angles are called x. One of them is called 5x minus 50. So over here, I substitute in the x with a 30, because that's the value of it, and I get 150 minus 50, and that's 100. From there, I'm going to look at the angle at the top left of the triangle, where it was 2x. That's 2 times 30, and that's 60. And finally, I'm going to go with x minus 10, where x was 30, and 30 minus 10 is 20. Remember, you should be accessing your assignments via Google Classroom. If you're still using Pupil Path, it's time to switch over. Okay, Mr. Omari made an excellent video on how to do that, which I put on Pupil Path for you to watch. If you don't have that, send me a message and I'll resend it to you.